All right, so we have everyone here. We'll get started. Okay, so yesterday we talked about the average and instantaneous oscillation. So the definition, so if you are looking for average oscillation, you do difference of the velocities, initial and final, and then divide by difference in time t. On the other hand, if you are looking for instantaneous oscillation, then you do derivative of time t with derivative of the velocity with respect to time t. Okay, so time derivative of your velocity. Then you plug in the specific time instant to get that instantaneous oscillation. Okay, and earlier similarly we talked about average velocity and then instantaneous velocity. You do the same, but change in displacement over change in time t gives you average velocity, and then instantaneous velocity you do time derivative of the position. Okay. All right, and then we check on the equation of motion. So these are the 5 equation of motions you would need for any other one-dimensional constant oscillation. Okay, so the condition is this one-dimensional, and then second it's constant oscillation. Okay, under these 2 conditions, then these 5 equations are valid. Okay, you can use just some of this are combination of couple of them, or maybe just one equation to solve some of the problems. Okay, so we are going to pretty much doing problems solving practice today. All right, utilizing these 5 equations. So the first one here, it states that on a ride called the detonator at Walls of Farm in Kansas City, passengers oscillate straight downward from rest to 45 miles per hour in just 2.2 seconds. 2 questions here asked. What's the average oscillation on the ride in meters per second square? And then the second question, how high have the passengers descended in this journey? How many of you guys have ridden on such thing before? How did you like it? Cool. Was it scary initially when you were up there? No, you guys like it. Yeah, I did one time too. Yeah, my friends and I were in the fun park like this, and then we actually didn't want to take this. We were like, oh, this looks scary. We'll wait. But then there was like lines, long lines, so we were just jumping on one line. We didn't know what that line led to, so we were in the line, and after 2 hours, we were here just to take that one. Okay, and we say let's do it because we have been here for 2 hours. We're just waiting, so why don't we do it? Yeah, yeah. I mean, it wasn't too bad. I kind of like it too. All right, but let's take a look here. So in this question, so the passengers, they're just going straight down. Okay, so this is just one-dimensional motion. So you pretty much can rely on those 5 equations, or maybe just one, or maybe 2 or 3, or sometimes 3 of them. Okay. One-dimensional motion. Okay, so the first thing here we can determine that, and then there are several given norms. Okay, there are the time given 2.2 seconds. So it says that passengers oscillate straight down from rest to 45. Okay, so in this statement, it actually tells us the initial velocity, which is 0, right? It says from rest. Okay, so anytime when you see that, it means your initial velocity is 0. Okay, starting from rest. 245 miles per hour. So this is your final velocity also given. Okay, so 45. But you may want to pay attention to the units given here. This is in miles per hour. All right. Now this is in seconds. So your final answer is in meters per second. So you probably want to convert this guy into meters per second first. Okay, the final velocity. All right. Yeah, I'll let you guys have a try, and then we can take a look on the solution together. Okay. When you have your answer, you can click on the link here and then submit it. Okay. All right, so I think we can take a look at the solution together. Okay, I see most of you, um, yeah, most of you guys submit your responses, and then for part A, you all agree that it's about 9.1. Some of you guys says positive, some of you guys negative. Okay, so I get it focused well. All right, so I think we know that initial velocity is 0, and then final velocity is 45 miles per hour. Okay, so let's first take care of the units of the final velocity here. Let's convert it into meters per second. So we want to get rid of miles and then make it in meters. 1609 meters in 1 mile, and then we want to get rid of the hour to be in seconds. 3600 seconds in 1 hour. Okay, so this gives us 20.1125 meters per second. You can keep 3 digits here. That's fine. Or you can leave it with all the digits. So out of the 5 equations, you can see you probably can just skim through and then see which one apply or which one will help you solve the problem. Okay, so it looks like this is the one we want to use, right? So V equals to V0 plus AT, that's the one, because we are looking for A, the oscillation, and then the rest of the quantities are given. So T is given as 2.2 seconds, okay? All right. Now, one thing we haven't done here is to pick up a coordinate system, okay? So this is one-dimensional motion, and then the passengers are going downwards in direction of vertical direction. So you can take the vertical direction, okay, to be your X. So it doesn't matter. You can say Y if you want, okay? So I'm going to just say this is my X direction. All right. Now, because the motion is going downward, so I can say downward to be positive. So again, the origin is arbitrary. You can pick any place to be origin. Also, you can make the direction to be arbitrary, positive. So you can say downward to be positive. Usually, typically, people take upward to be positive. Okay, so that, but it doesn't matter. You can say minus, okay, to be, or you can say downward to be positive. So I think that's why some of you guys got positive for A. That means you are picking downward to be positive, okay? And then some of you guys got negative. That means this simply means you pick upward to be positive. So it doesn't matter, okay? So if that's the case, then your final velocity is positive, okay? If you pick this to be positive x direction, then your final velocity is negative, okay? 20.1125 meters per second, okay? Once you take that, using this equation to solve for A, you'll figure out then A will be negative in that case, okay? But we'll just take this one here, all right? It doesn't matter. So the algebra here, you can solve for A here. So A then will be equal to minus V minus V0 divided by T, okay? This is exactly the definition for average oscillation. My final minus initial divided by time T, okay? So then you do 20.1125 meters per second minus 0 initial divided by 2.2 seconds. Okay, this tells you roughly about 9.14 meters per second square. Okay, so the positive indicate this is going downward. Okay, in this case. All right. And then a couple of you guys says negative. I'm assuming you are picking upward to be positive direction. Okay. All right. B is asking how high has the passenger descended through the journey. Okay, so that means you are looking for the final X, right? So if initial X, that's where you pick to be 0. So then that tells you X naught is 0. Okay, then you just need to figure out what's your final X, right? So then you're looking for final X. Now you check through the 5 equations, you probably realize either the first one, yeah, I think you're going to use the fourth one. Let me take a quick look on the equations here. The first one, it has X in it, so X naught is 0, and then V average, you have to figure out V average here, okay? So this is again, the common mistake people make. Take V average as final, okay? So if you put final in the place of V average, then you'll get twice of what you should get, okay? So if you want to use the first equation, then you want to use the second equation first to figure out your initial velocity, or your average velocity, okay? And then take the average velocity into that first equation, okay? But it looks like I can just use the fourth equation directly, because then I'm looking for X. So everything else is known except X, okay? So I can use the fourth equation here to solve for my final position. All right, so I can use the X equals to X naught plus V0 t plus 1/2 AT squared, okay? The X naught is 0, where you pick your origin to be X naught. V0 is 0, so then first two terms will be 0, okay? Your X then will be 1/2 A 9.14 meters per second square times 2.2 seconds square, okay? So then 22.12 meters, okay? Many of you guys got this one right as well, okay? So then that's your the height, okay? How high have they descend? Now also you can use another way of solving this. So let's say if you want to use the second equation first to figure out your average velocity, okay? So V plus V0. So then 20.1125 meters per second plus 0 divided by 2, which gives you 10 looks like 0.5625 meters per second, okay? Then you're going to use this into the first equation, x equal to x naught plus v average times t. So then x naught is 0, so it'll be just the average, okay? Velocity times 2.2 second, which should also give you this number, okay? 22.12, okay? So some of you guys might use this method, okay? Or might be using this equation, but keep in mind that's you want to take the average velocity here, okay, not the final. Now, there's indeed another way of solving for this. Use the last equation using the v squared equal to v0 squared plus 2a x minus x naught. Again, v0 is 0, so this term goes away. X naught is 0, okay? So then on the right-hand side, you only have this remaining. So your x then will be equal to v squared over 2a, okay? V is the 20.1125 meters square. You do the square of that, divide by 2 times 9.14 meters per second square. You should also get 22.12 meters. Okay, so yeah, either way, I mean, any of these ones, like method 1, 2, or 3, any method you pick should be fine. Okay, all right. So many questions will have multiple ways of solving it. Okay. Just pick the one you feel most comfortable of doing it. Okay. Questions you guys might have on this one? If not, then we are going to check the second example here. All right. So this one says a rocket blasts off and moves straight upward from the launch pad with constant acceleration. After 2.8 seconds, the rocket is at the height of 91 meters. What are the magnitude and direction of the rocket's acceleration, and then what's the speed at this time? Okay, go ahead and give it a try. Again, you'll be just looking at those 5 equations and then pick one or maybe 2 or 3 um, on this one, okay? All right, so let's take a look here. Again, you can see that the rock, because the rocket just goes straight upward. Okay, so this is one-dimensional motion here. So then we'll be just checking on one of these 5 equations, or maybe 2 or 3. Sometimes you have to use 3. Uh, but it tells us that the time it takes. So let's say this is where the launch pad. Okay, we can take that as our origin of our coordinate system. So the rocket goes straight upward. So I can take the upward to be positive direction. Okay, I think it makes it easier that if an object is just going in one direction, then no matter which direction that you take that as your positive direction. Okay, so then that would be easier. You don't get the extra negative signs over there. So it blasts off. So that means also so this is your initial position. Then that means also your initial velocity will be 0. Okay. We know how rocket is launched, so it's starting from rest and then goes straight upward. Okay. So it says after 2.8 seconds, t equals 2.8 seconds. It's at 91 meters above. Okay, so that means your final position is 91 meters, all right, after 2.8 seconds. Okay, so these are the knowns, and then we set up the coordinate system like that. Part A is asking you what's the acceleration. Okay, so to solve for the acceleration, again, these are the 5 equations you can use. Now you just check on them one by one. The first 2 don't have acceleration in them. The third one has acceleration. Okay. And then you can see that, but you don't have final velocity. Okay, you have initial velocity, you don't have final velocity, although you have time t. So this is an unknown, the acceleration is unknown. You cannot solve 2 unknowns just using one equation, okay? So probably not that one either. The fourth one here, you know the final position, initial velocity times t. Acceleration is only unknown. So it looks like we are going to just use the fourth one to solve for A, okay? And then the last one, you can have a quick check. This one has a V in it, which is unknown, and then A is an unknown, so you probably don't use that one. So it's the A that will give you the acceleration. So you are going to just write the equations over here, okay? And then before you plug in any numbers, you can see which numbers are 0, you can get rid of. So this one is 0, this one is 0. We'll give you a 0 from V0 times t, okay? So then x equal to 1/2 at squared, okay? So you can do 91 meters equals to 1/2 a times 2.8 seconds squared, okay? You can solve for a, both sides multiply by 2 to get rid of the 1/2 on the right, okay? So 2 times 91 divided by, and then divided by 2.8 squared, okay? So then your acceleration on the left hand side is 91 times 2 divided by 2.8. So 91, 2 times that divided by 2.8 square, okay, equals to your acceleration. So this is in seconds square, so meter over second square, okay. Now, many of you guys get the first one, the first answer right, but some of you guys are having a factor of 2, so I suspect that's from here, the 2, okay. And then also maybe off by about 2.8. So that's forgetting this square. So there's a square here. There's a 2 factor here, okay? But other than that, this should give you acceleration equal to 23.21 meters per second square, okay? Or 23, roughly 23, okay? If you do approximation, so 23 meters per second square, okay? So that's A. All right. Now B is asking you what the final speed at this point, okay? So I guess the ones you don't have the A right, then you couldn't have B right, right? Because B is directly from A. So Again, looking at those 5 equations, you probably figure out this is the one you want to use, okay? And then that will give you the answer directly, okay? So V, you're looking for V final should be equal to V0 plus A times T, okay? So initial velocity is 0, then you are doing A, which is the 23.21 meters per second square, okay, times 2.8 second, that will give you roughly 65 meters per second, okay? All right. So once you figure out A and B, a little bit easier on this one, okay? Any questions you guys might have before we check on the next one? Okay, if not, then we'll check on the next one here. Yes, yeah. Right. So it's speed. It's the magnitude of your final velocity. Okay. So you might get velocity as negative 65 if you pick downward to be positive. Okay. But then in this case, then you want to report as the magnitude. Just take the 65. Okay. So when it's asking for speed, it's going to be positive always. Okay. Yeah. All right. So next one we'll look another one, and then you guys will be out of here out after this one. Okay, so this one says as you drive in your car at 50 meters per second, that's roughly 35 miles per hour. You see a child's ball roll into the street ahead of you. So that tells you the child may be coming on the street to get a ball. Okay, so you realize that, then you hit the brakes and then stop as quickly as you can. In this case, you come to rest in 1.5 seconds, assuming that you had a constant deceleration of 10 meters per second square. How far does your car travel as you brake to a complete stop? Okay. So let me make also a Google form for you here for you to submit your responses. All right, so looks like most of you guys agree with each other 11 or 11.25. Couple of you guys said 34. So we'll take a look here. I think it gives us a lot of information. So let me take a quick look on here. It tells your initial velocity is 15 meters per second, okay? And then it tells you you come to a stop, and then t equal to 1.5 second. Deceleration is given as well, okay? So let's see. So again, we want to list the knowns. Initial is 15 meters per second, okay? Now, again, so it just have to do like which direction you choose to be positive, okay? So again, the car is going in that direction, so it's most convenient to take in that direction to be positive, okay? And then final, because you come to a stop, the time it takes 1.5 seconds. Your deceleration is 10 meters per second square, okay? So in this case then, because it says deceleration, so that means your acceleration is actually in the opposite direction, okay? So this will be your acceleration. So then this is negative, okay? So this is one thing you probably need to pay attention to, okay? So this is negative. It's negative 10 meters per second. If your velocity initial is positive, then acceleration should be negative, okay? All right, so we have 4 knowns here. And then because you take this as origin, that tells you that x0 is 0, okay? So also we know x0 is 0. And we are looking for x. All right. So again, you check on the 5 equations for one-dimensional constant acceleration motion. Then you are looking for x, okay? So you can use this one. In addition to this guy, right? So this will be, you figure out the first average velocity first, and then take that into this equation because this is given. So then you can solve for your final position. All right, you can also use this one because everything else is given, okay? Or you can use the last equation, okay? So any one of this will help you, okay? So I'm going to just use the last one here first, and then we can take a look on this one, okay? They should give you the same answer, okay? So the first method, I'm going to use the last equation, the v squared equal to v0 squared plus 2a x minus x naught, okay? So my final now this time is 0. My initial is not, okay? My initial position is 0, okay? So then you can say 0 equals to, this is 15 meters per second square plus 2 times negative 10, okay? It's negative times x, okay? Then you can solve for your x. This gives you minus 20x, right? 15 squared will be 225 minus that equal to 0. So then you can take this guy to the other side equation, tells you 20x equal to 225. So then divide by 20, that gives you 11.25 meters or 11 meters, okay? So it looks like the 11 or 11.25 will be the correct answer here, okay? Now, as I say, you can use a second method. You can do the fourth equation, x equal to x naught plus v0 t plus 1/2 at squared, okay? So this guy initial position is 0. Then you're just taking 15 meters per second times 1.5 second plus 1/2, now negative 10, 1.5 second square, okay? So meters per second square. All right. So then this should also give you the 11.25, okay? Also, as I said, you can use the second equation first to figure out your average velocity, 1/2 v plus v, or v0 plus v, will be just the 15 meters per second plus 0 divided by 2. So 7.5 meters per second, okay? And then use that into the first equation, x equal to x naught plus v average times that. So this is 0. So then 7.5 meters per second times 1.5 second, okay? Should be the same. Okay, so again, this one you can have multiple ways of solving it, okay? All right, any questions you guys might have? So if not, then we are going to stop here for today, okay? I'm coming back on Friday.